So on page 23 of the packet, still in Unit 2, we're going to talk about logical connectives. This is a precursor to more explorations involving probability, specifically conjunctions, disjunctions, and implications. And so on this page, we're really going to focus only on conjunctions and disjunctions, but when we get to conditional probability, we'll talk about implications. All right, so like I said, we're going to focus mainly on these two guys. All right, so what's a conjunction? Well, a conjunction is that almost and symbol. If you look at it, it looks like kind of like an almost, the letter A for and. So there you go. If you have a symbolic form of P upward arrow Q, that's read as P and Q. All right. The important piece is the condition here. Only if both the values of P and Q are true does this expression evaluate to be true. All right, so both parts of the sentence need to be true in order for the whole sentence to have a true value. All right, a disjunction is, the reflection of that, an upside down and symbol, or a V. P, V, Q is read as P or Q. As long as at least one of the values P or Q are true, then the whole shebang is true. All right, so if either part is true, then the whole thing is true. All right, so in terms of just raw context, kind of look at it like I am qualified to teach this course and I am getting paid to teach this course. All right, so if both parts of those two things are true, then the whole sentence is true. I am qualified to teach this course and I am getting paid to teach this course. Right? It's not a conditional. The conditional will be, if I am qualified to teach the course, then I will get paid for it. That kind of seems more appropriate, but that's not the sentence that I uttered. The one is, if I am qualified to teach this course and I am getting paid to teach this course. All right, true and true. All right, if either part of that was false, then the whole sentence would be false. All right, so if I said I am qualified to teach this course and I am getting paid to teach this course, and then he said, well, wait a minute, I don't think you're getting paid for this, then the whole sentence is false. It doesn't really matter what the first part of the sentence is. The whole sentence is invalid. You can look at something even simpler, like I am wearing shoes and socks. All you have to do is look at somebody's feet. Are they wearing both shoes and socks? Yep, true. No, they're missing the socks, but they have the shoes. False sentence. Missing the shoes but have the socks. False sentence. Missing both. False sentence. All right. The only way it's going to be true is if they're wearing both those shoes and those socks. So those hot dogs better be covered. All right. Now the disjunction would say either part of the sentence has to be true in order for the whole thing to be true. So I am qualified to teach this course, or I am getting paid to teach this course. So let's say turns out I'm not getting paid for it, but I am qualified to teach the course. I mean, you're probably a better judge of that than anyone else. I mean, if the stuff I'm saying makes sense, then probably qualified. If not, then maybe I don't know about this guy. All right, so you say that I'm qualified to teach this course. So then the whole sentence is true. Doesn't matter if I'm getting paid or not. All right. From your perspective, it very much matters if I'm getting paid. You gotta put food on the table, right? All right. So the other possibility would be maybe, again, the sentence is, I am qualified to teach this course, or I am getting paid for it. Well, what if I'm just getting paid for it? That's kind of disheartening. I'm getting the money, but not really qualifying to teach the course. That can kind of blow up pretty badly, right? So yeah. Now, again, a simpler example, the shoes and socks. I'm wearing shoes or socks. All right? Makes it seem like there's a choice. Like, can't be wearing both, but actually you can, because if either part of the sentence is true, then the whole thing is true. So if you look down at those little piggies and you see either shoes or socks on that person's foot or feet, then you can identify that sentence as being true. All right. Now, a Venn diagram gives us a nice visual in terms of comparing the relationships between two sets. The only thing is, when we get into probability, there is the bridge, and it's kind of frustrating because, and you might have seen this before, or you might have seen this in this very class where you think, I'm used to writing it this way, like think of linear regression. We talked about lines. You think about writing the equation of a line, maybe you think y equals mx plus b, but here I am writing it as a plus bx. Sometimes I forget and I accidentally start writing ax plus b or mx plus b, because I even get my wires crossed. Right, let me just pause. So the notation, so this upside down u in probability notation or Venn diagram notation is the same as A and B. The U itself is the same as A or B. So it's just getting used to the notation a little bit. All right. But when we talk about the intersection of two sets, specifically A and B, what we're talking about is the parts of those sets that are in common with one another. So what I'm going to do here is I'm just going to color code a little bit. I find that helps. And if I can get it so that, it actually follows the rules of like primary and secondary colors, that's even better. So let me go with maybe a yellow. Yellow. Yeah, precisely. Yeah, Schlemiel. Talking to myself, by the way. Now, invariably, there's going to be someone who's going to say, can you use a darker color? I can barely see that yellow. I understand, but I'm doing this for a reason. I'll brighten it up or I'll make it more noticeable in a couple of minutes. All right. So we have set A, which would be the values inside circle, the one of the circles. So I'll call that circle A. And then set B. All right, I know it's barely visible, I apologize, but let's just bear with me for a minute. All right, so everything inside of A is part of that set. And what I mean by inside of A, I'm talking about inside of that circle, the circle associated with A. All right, everything inside the circle associated with B is going to be the set of B, or set B. All right. So now, like I said, I'll darken it up a little bit. I just wanted to make it kind of pop, and the hope was that maybe it would kind of show up as yellow and blue make green, show up a little bit of a green in the middle, but in that interval of overlap between the two, we have. Just imagine it beautifully shaded in green. We have an overlap, which is the set of A happening concurrently with the set of B. All right. So in this case, it's the overlap that we care about. All right. So what I'm going to do, and this is gonna look weird for a sec, but just like I said, bear with me. It's all about, when it comes to diagrams, it's all about bearing with me. All right. So I'm just going to pull this off, copy, paste. I'll put it back. Well, actually, I need that off for a second. All right, I'm going to do a screenshot. And the question I get is usually, well, why wouldn't you do this in advance and just fill it all in? I actually want to show you how you construct an appropriate Venn diagram. So what we had come up with initially was this beefy diagram with the bright yellow and all that good stuff. All right. What I'm saying here is that if we just kind of trim this down by getting rid of all this extra fluff, everything that's A but not B, and everything that's B but not A, you have that little football looking thing. That interval, that little region there, that's the only thing that we're considering as part of our solution, and why it didn't show up. It's kind of strange. Yeah, I don't think it's gonna, I think it's gonna hide behind it again. Ah, sneaky. What can you do? Oh, because it's an image. No, it's convert to text, so it's not good. All right, well, what I will have to do then is I'm going to have to do this the old-fashioned way. But fortunately, I only have to do this the one time and it'll all be fine. And then just draw a couple of circles in there. Yep. Duplicate. So one thing that you won't have to be concerned about, because I gotta imagine somebody's very worried about this right now, I'm not going to ask you to draw the rectangle with the circles in it, just the stuff in between or within it, you know, the coloring part. All right. So, oh, let me save this so I have it for later. But again, it's just this piece here that we're interested in. All right. So that's the set of A and B. And so another word for that, oh, sorry, I put the wrong symbol there. Jeez, falling apart. Another symbol, or another word for that symbol is intersection. All right, so, and that's actually written in the notes. So the intersection of two sets denotes the elements. The union, well, union will help you remember U, but intersection, the term intersection helps you remember actually what you're looking for. So it's what's in common between the two. All right. So when we're looking at the union of two sets, we're looking at, you know, kind of combining forces. All right. So with that in mind, it's actually a whole lot easier to consider what a union would look like, right? Because it's going to be kind of the same setup. We're going to have these same diagrams, except we're not going to be just looking at the overlap in between the two. All right, so I can get rid of all this. Copy. And then bring it all back. And then paste. All right, because I have my set A and B here, but I'm really looking at, all right, so what would I have if I were to unite the sets, unite the clans? Well, I'd have all the assets that A possesses combining with all the assets that B possesses. All right, so that would be everything in both circles. All right, so what's mine is yours, and what's yours is mine. That's what we'd be looking at when we're talking about the union. All right, so how did I remember it? Well, kind of look at it like marriage. If two people get married, they're supposed to unite their hearts and minds and all that good stuff. Oh, if my wife hears me say that, that's not gonna end well. And all that good stuff. I probably got to come up with a better way to phrase that. But unite, themselves, as people, but also their belongings. Like what's mine is yours, and what's yours is mine. So that kind of makes sense. Everything that I have, you now have access to, and everything that you have, I now have access to. All right. And union, matrimony, marriage, union, the union of two people, it kind of goes together. The complement's pretty nice, because when you're dealing with that, it's in terms of a visual. Now we're going to be done with a really hard to look at B. A, again, is everything contained within that circle A. But if I'm telling you that I don't want A, I'm saying I want everything but A. I'm not only saying that I want B, I want everything beyond. All right, so that would be all of this stuff. I could probably do a better job drawing here. I apologize, because I know half the runtime of this video is just watching me fumble around drawing stuff, but the hope is that it's at least somewhat valuable. I'm kind of like going for a self-deprecating thing right now, but also I am very, very aware that I'd be like, if I were a student, like, dude, come on, pick up the pace here. And I do feel bad about that. However, you could speed me up. That part is all right. I take no offense to that. Just don't skip too far ahead. All right, you don't want to miss important stuff. All right, so finally, I have the whole set. So it's everything but A. But you see that it's not just including B, it's including everything. So think of it as heads or tails, right? So I don't know if this has ever happened to anyone. It's never happened to me. But whenever I talk to my high school students about flipping coins, when we get into probability, we talk about heads or tails, right? And then they say the what if thing. I think they just want to kill time. So they say, well, what if it lands on its side? Like the ridges, like not heads or tails, but the circumference of the coin. And I would say in my mind, well, what if you actually took math seriously? And then I also think, like, no. But out loud, I have to say something else. And it's usually something along the lines of, that's negligible, because I don't know what the probability would be of that, but it can't be significant, because people don't really take that into account when they talk about flipping a coin. Like if you go watch a football game, right before they start the game, they do the coin toss to see who's going to get the ball first. They don't say, all right, what's your call, heads, tails, or other, because it's negligible. If it landed on its side, they would just do it again. All right, so there's that. But then the other aspect of it has to do with just the idea that even though it's a minimal probability, we could also make this a binary situation by saying, instead of heads or tails, you could say heads or not heads. Right? So heads are the opposite of heads, or heads or everything besides heads. And so that other category would be a catch-all of tails and every other weird outcome that could happen. All right. So would it be 50-50? Probably not, but it can't be too far off. Otherwise, people would say, all right, heads, tails, or other. Heads, tails, or ridgies. So that's just something to keep in mind. But the diagram itself is very easy. I could have done the same thing with the B, so let me just do a quick sketch of that. Like, not again, another sketch. This guy sucks. No, this guy, but I try, man. I'm trying my best. No, this one should be a lot quicker. So let's see if I got this part down. All right. So it's not great, but it's better than waiting, right? But I can move some things around a little bit. Nothing like a little dead air. And just kind of, there we go. A little quicker. All right. That's the plan anyway. A little reflection, but should make things a little bit more manageable. The idea is you don't want to get bogged down with that, but you also don't want to lose the flavor and the understanding of it. All right. So the example that follow, on a Venn diagram, shaded regions corresponding to A union not B. All right, so that could be kind of tricky, because if you try to reason it out in your mind, sometimes they're easy enough for you to do that, and sometimes it's like a little bit in the neighborhood of mind bending. And so it's going under the umbrella topic of you just got to be careful. So what I like to do is draw or sketch out a couple of rough drafts and then merge those rough drafts together and then put my final product on the main answer sheet or form. So what I would do is I would actually plot out A, and not B, just in two separate Venn diagrams. And then, like I said, I would merge them together later. All right, now I don't want to lose these because I put so much time and effort into it. And I also need these to be so if I mark this as A would be just the stuff inside that circle. Let's see if I can make red work. I'm going to make these red. So not B is a little trickier because, well, B would be everything. B would be everything inside of this circle. All right, so everything inside of here, but I don't want that. I want everything outside of there. So what I would do is get rid of the shading inside. Oh, I forgot this is actually a fixed diagram. So I have that shading, and then I would just get rid of everything in between, or everything within the B. So I'm going to try something, hopefully it'll work. Didn't really. All right, I'm gonna try getting cute there. So it looks like I'll just have to shade it the old-fashioned way. So all of this stuff is not B. All right, so then what I do, so I'm just going to merge the two sets together. Now I just have, there's the thinking step here that involves us acknowledging what the true meaning is of, oh, well, that didn't work out nicely. Again, that union idea is the idea of the marriage of the two sets. So anything that has some shading in it will be part of the solution. All right. So basically, anything except for that unshaded part of B. All right. So when I'm coming up with my final answer, it really is just a matter of saying, okay, it's going to be, well, I should probably use a better color than that. So I'll use purple. So it's that little moon-shaped part of B that doesn't include any aspect of A. And so that would be the appropriate Venn diagram. All right, so there's a little bit of thinking going on here, but it's manageable if you have a structured approach. Now, there are some people who can just kind of look at it and say, oh, that's my answer. I got it. No problem whatsoever. But then there's just as many people who are like, oh, hold on, I need a more structured approach to this sort of thing. All right. So here we're looking at A intersection of not B. All right. So I actually want to have my same diagrams. So I really don't need these pictures for this one. I need this stuff again because we've already merged the two independent sets of A and not B, but this time I want the intersection. So in this case, I'm looking for the part of the graph that is shaded in a, I don't even know what I was going to say there. I was going to say like doubly so, you know, but it's got to be shaded for A, but also shaded for B. If I could ever get the color scheme to work out, I always envisioned that when I would shade in red and then shade on top of that in blue, it would be the purple part because red and blue make purple. But here it's just, you got some of it shaded in blue and then also shaded in red. What part of that is that? That would be, this would be really great if this would actually work out. It would be this part. Yeah, that makes sense. So it would be this portion of the Venn diagram. All right. So why is this important? Well, if I ask you a probability question and that question says something like, what is the probability that you're going to select a red card and a number that is not a prime value? If you could simplify just using your knowledge of probability and logic, then you could actually come up with a much simpler expression in order to find those results. All right. So A union B, well, we've already kind of figured that out above. This is saying not that. All right, so we've already discovered that A union B, here's A, here's B, so I'll label this A, label this B, if I merge the two sets together, then I would have the union of A and B. All right, and again, the union is the case where, you know, it's the marriage of the two sets. A and B, married, happily ever after. All right, so A and B are, they got the cans that are tied to the back of the car, and they're driving away. What's mine is yours, and yours is mine. All right, so what I'm saying is not that. All right, so the answer to this one would be everything outside of those two circles. As opposed to number 4, which says not A, intersection, not B. So for that one, I want to be looking at what it means to find the overlap between two sets that are related to opposites. All right, so let me draw the picture again because I didn't copy it before I merged. And so here we are. All right, so this is my ordinary diagram. I'm going to split it up. I'm going to denote what not A looks like. So not A, here's A, so everything outside of A. Not B would be everything outside of B. So I want the intersection of those two things. So I'm going to put these two together. And look at that mess, that's hideous. But any overlap between those two sets. All right, so I'd have to change the color there to make it something lighter. I'm just going to live with the red or the yellow for a second just to make it a little easier to see. But anything that's double shaded, all right? So you could see hopefully inside A, it's not double shaded. Inside B, it's not double shaded. The overlap between the two is not shaded at all, so it couldn't possibly be double shaded. The interval over which it's actually double shaded would be everything outside of the two circles. All right, so it's actually, surprisingly, exactly the same as this. So what we just discovered is a nice little relationship that tells us that you could have multiple expressions, even complicated ones, that are equivalent. All right, so we just learned, so therefore, 3 dots in the form of a triangle means therefore, not A union B is logically equivalent. So we use a double-sided arrow to represent logically equivalent to not A intersection B, not A and B. All right, so that's something called De Morgan's laws, or one of De Morgan's laws. It's not necessary that you know that name, but it is necessary that you start to understand that there are other ways to represent expressions logically, right? And the logic of these things is going to be a driving force